3D modeling in Fusion is pretty cool, I know. So that's why we are going to make this water bottle. It's very difficult. In this exercise, I will show you an interesting comparison of what a concept model done via solid modeling is, and then based on that, we create a new parametric model that's based on just a sketch and modeling features. So you see there's actually the sketch and then all the few modeling features, and here there's no sketch because everything was just initially created out of the geometrical basic shapes. And that's an interesting process and workflow to be aware of. Okay, let's get going. Okay, so to start, we go to create and go to cylinder. When we create a cylinder, we can specify the plane. We want this to go vertically up. So I select the ground plane, click, and then go to the center point, click. And what I'm dragging out is actually the diameter. This should be 66. So I can type this in. So this is the diameter. Or if we know just the radius, which is half of it, 33 multiplied by 2. Pretty cool. The height is 160 and enter. And then you see then the timeline captures the cylinder construction. The nice thing is we can double click and then later adjust everything. See, just by dragging or entering it. Cool. So this is the main bottle body. And now we need to create a neck. So we go to cylinder. Putting it onto the ground or these vertical planes is kind of silly. And because we have a flat surface on top of the cylinder, you see we can sketch on it. So click. There's again the center. Drag this out. Here I know the radius only 11.5 multiplied by 2. Very good. And then the height 22. And you see when we create a new cylinder or a solid and that touches another solid, the operation instantly thinks, okay, we want to join them. Okay, there we are. Now we have only one object. Pretty cool. When this is a bottle, we will have here a little ring going around. Okay, so how do we do this? Easy. Cylinder on top, click from here. Now this is the diameter 23, and then I would like this to be 4 millimeters further away. So this is actually the diameter plus 8 millimeters on the left side and the right side. No, radius. So 8. That means this is 31 millimeters. Enter. And then this goes down actually. Let's say 2 millimeters. And you see how this cuts because it is intersecting. And the software thinks we want to cut, but we don't want that at all. We want to make a new body. We make a new body. You see we have an object. And the reason why we did this is now we can go to move copy. We don't have to change the position of the widget. We can, if we want to be super precise, bring it to there. Click OK again. And then this goes down by minus 15 millimeters. Oh, I have to be careful. There. Minus. Okay, very nice. Here now we have two objects, the lip and this part. And we would like those to be fused together. Here is the tool for that. They call it combine. It's more actually a Boolean volume operation. That basically means we can add, subtract, find the difference. So here we have our target, our tool, cut or join or intersect. Obviously, we want join. Very good. Now we have one. Very nice. Since we're working here on top, we would like to create also a cap that goes over it. Okay, that's easy. So cylinder there and click. So let's say material thickness 2 millimeters. So we need to add 4. So 27 it might be. Actually, let's say 28. That's good. So how far does this go down? We brought this one down 15 millimeters. Let's say minus 14. So we have a small gap. Also here, new body. Okay. Now you see that the top in here, this all sits together. That's not good. So this needs to be a little bit higher. We go to faces. Now be careful that we don't select the bottle face, but just the cap face there. And then this face we can move up, let's say 2 millimeters. Very good. Not too bad. Now, this, however, is just a solid cylinder. We need to core the stuff out. Now we could actually create a new cylinder here on the inside there and just drag it in and cut it out. That's way too complicated. We have this body, the bottle we can use to cut it out. So we go to combine. You are my target. My tool is this one. Cut. Very good. And we want this keep tools on because now when I click OK, the tool remains being there. And you see how this actually got cut out. Pretty cool, no? Yeah, I think so too. Let's bring this quickly to an end. The bottom part we would like to be domed. Okay, well, we have a sphere for that. Click. I don't know really how big this is. Maybe 80 millimeters. New body. And now this sphere, we simply move down till we can see, does it intersect good? I don't know. The spheres may be too small. We can adjust the size. Then I might have to double click adjust the position. You see I just double clicked on this move command. I'm not adding a new move command. Okay, let's go combine. So you, from this time now here, do not keep tools. I want to get rid of that sphere. There. Yeah. Not too bad. Maybe a little bit of cleanup. Fillet. We can click this edge and then drag this one. Constant here in this case is fine. We go with 16. That is good. Then, since I'm working actually on the bottle, maybe 1 millimeter there. And here, 6 millimeter, maybe 5. Okay, right click, repeat fillet, or you just go to fillet again. 2 millimeters. So in this case, 2 is too small. 4 looks actually good. Okay. And then the last fillet, maybe here. 1, a small one. Yeah, that looks good. So at that point now, the last step is, if we want, we could also core this one out. So we made a very quick, solid model of a water bottle without any sketches, and only we're using literally cylinders and spheres, and then more of the modeling commands, shell, combine, and also move to position everything. Let's take a look into the inside. Now, even there, everything is nice and beautiful. So this is a very fast method to build something. we can literally adjust everything later. That's the nice part of fusion and parametric modeling. Maybe the bottle is too high. Okay, let's make this 120. There, awesome, everything adjusted. Let's maybe go to 160 back. So how does this actually work? So this is the timeline when I change the first cylinder, and then the software continues doing all these commands. And because I created all these new cylinders on existing geometry, it got referenced. And that's it. That's the whole beauty behind it. The downside of this type of modeling without sketches is, well, I only can make this dome with a sphere. If this should be maybe an elliptical shape or anything else, I can't do this. Also here, this face which I selected, instead of horizontally, maybe I would like this to be more at an angle, and it's not possible with what I have here. I could, technically speaking, go ahead and go with chamfer and chamfer this edge, and then say 2 distances, so this goes really far in. This may be less, but then I'm making this shorter already, and I have to readjust the first cylinder here I created for modeling this. So this is, technically speaking, possible, but not that super easy. So maybe I just add this at the end and leave it at there. Okay, so again, this is just only a concept model. It is fast, it is not as detailed, and that's good because of the speed, how I can explore an idea. Now in the next video, then I will show you how we take this idea and build everything just from with sketches. And then I will show you that it is actually not as fast, but I can get more details modeled the way how I want. So each method has really their advantage and disadvantage inside a design process. So if I explore an idea very quickly to make variations, I might go with this simply because it's faster. And then when I know what I want, then I go and rebuild the design with a cleaner, more detailed process. To make the new version, let's create a new design. We will save each one later separately. Front view, sketch here, very good. And then I can actually block everything out very easily just with 2 rectangles. Let's see, probably not. You see there are actually two lines. So undo, and let's just click up, click to the right, till it's on the green, click down there. And because I drew the rectangle from the center point, all this is vertical horizontal constraint. Very good. Escape. Now let's add dimensions. So we know this should be 22. And then this is just a radius, so 11.5. Then this radius 33 and this height 160. Very good. So finish. And now when I quickly do a revolve study to see how does this look. Okay, that's actually fine. Now I would like, how do we do? Let's actually work from the bottom up. That's also very good practice. When you design something, don't necessarily jump to different areas. Try to work methodology. Work cleanly. I can't say that word. Methodisch. In German, I can say that. Work methodisch. Let's make this course bilingual. So we make a line, and I jumped 1 step forward. I just double click now to go into edit mode. We make a line. Click, go to the right, escape, click this line, and then say that's a construction. Cool. And then we can go to 3-point arc from this endpoint to somewhere here, not the midpoint. Click, and you see when I move this arc, there's actually a tangency constraint popping up. See, it got automatically added. If you don't see it, let me redo the arc. Click, click, and go to here. Then we simply go tangent U to U there. Now this point we can move. So from here to here, these 2 points with shift selected, sketch dimension, that should be 6 millimeter. So we can specify this more, and then here to here, this should be 5 millimeters. And that already shows you how much more control I have actually compared to how more via eye position or eyeballing I needed to position the sphere and then move it down and then kind of like judge my gut feeling. But nothing is wrong with this way again because this is actually very fast. This is just more precise but also slower. Okay. So that is done. We would like to up here have a small lip. We will do this with the line. I'm simply blocking things out very loosely. Again, try not to snap this onto the midline. Let's say how I did this here, because then we can't move this up. We can, however, select the midpoint constraint, delete it, and then we can drag it. We need to specify dimensions. Sketch dimension 4, 1, and then the angle here, click this line, that should be 82. No, that's not correct. So 90. Oh, I see. Yeah, okay. Let's go with 100. Yeah, because 90 would be perpendicular. So 82, I actually then had this at 98. It was a 8-degree difference. Okay. Very good. Now the height position, we set this point to there. That is 15 millimeter. So the bottle actually at this point, we have the details in. So now we can double click on the revolve command. And I will simply turn, no wait, I will turn this one off. So click this filling. You see that? Then we can hold the control on PC or Apple on Mac OS. Click this one, do this one more time, hold control or the Apple key, click this one. So we add those to the revolve. Okay, cool. Okay, so we add fillets. So these fillets we can actually add now. Very good. So 16, very nice. Now I will actually do all in one fillet command. See how I click add there and add. This one was 2, actually 4, remember, plus here, this one will be 6. That's too big. 5, 4. Okay, so this one actually. So if I want this to be 6, then this arc needs to be smaller. Okay, so right click here and say, if it does do it, maybe click again with left mouse button, there, right click, show dimension, make this 8 or 7, maybe 7 is enough. Double click. So where is this value here? This is the 1 and 5. Okay, 6. That works. Very good. Then maybe here, this edge, we make 2, so we make it smaller. Okay. Or we can also make this distance bigger. That pushes this arc further back. So you see how I can fine tune this more. And what I'm doing right now, that is actually why some people say, well, cat is low, because you get lost in funny details, which is why even when this is not very precise, but when I'm just exploring an idea, this is totally fine and faster. That's also why I think about this as sketching just in 3D, not just pen paper. Okay, all this is pretty much done. That is nice. And now we can go ahead and do a shell on top, 2 millimeters. Section here. I was actually concerned that this might cut in, but the wall thickness is thicker than this, so it will not gonna create a cavity. Beautiful. Okay, well, a few more fine-tuning stuff. That's the cool part of this type of modeling. Okay, I would say actually the main body for the bottle is done, and now we can create the cap. Now I have two options. I can create a new sketch, or I can add it to the existing sketch. This is a very simple object. I will add this to the existing sketch because then I can really nicely sketch over it. So I will do something very simple on purpose. Again, a little bit Cricut, so we get a little bit of practice how the constraints work. So there, everything's vertically, horizontally constrained. This line I would be tangent to here, so we can make this point and this point be horizontally, vertically, I mean constrained, but it's going to make this horizontally. So undo. Now that means escape. We have to bring this closer over, so it is vertical there. Now this line is perpendicular to this line. Then we do not make this and this equal. So this one will be 1 millimeter. This we make 2 millimeters, so it just has more material. And then we can specify the distance, 0.5, just so we can see this. Normally it would be 0. And now here we can say, we later put a threading in. The threading is maybe 2 millimeters. Very good. We can specify a length here because, as you can see, the sketch is already black, but we can create what's called a readout. So this line is 14.5. And you see how this is actually sticking out wider than this one. So if we want actually this face to match this line, just so you understand what we have to do. Okay, so then this we need to remove, and then we could say U to U vertical constraint. Okay, so you see now how this actually did a readout. What's actually the distance? Let's see, I'm curious. 2 millimeters, okay. Yeah. Okay, cool. Yeah, let's make this equal. Zack. Oh, this didn't work. Why didn't it work? Oh, yeah, we have this distance here too. So this specifies 2 millimeters, and then this constraint specifies this to be here. So these two lines are specified, which generates just a line or length. By surprise, this is 2 millimeters. If we want this to be truly 2 millimeters here, 2 millimeters, but you see now we will get the warning actually at this point. Okay. I hope actually this starts to make sense with how we can add dimensions, because what you cannot do is you cannot over constrain or over dimension. There's a limit to it. Now this is still blue, so maybe from this point to this point, but not aligned, but vertically, I would like to have a small gap of 1 millimeter. So down here I have a fingernail, I can just push down and rotate the cap up. Very good. Now what do we do now? So the cap is there. Can we actually, we could put this in here too. Actually creates then two objects. So you see, if we want to, yeah. Or if I undo, this is maybe more logical. Now we make a new revolve command. Very good. And then there, here, very tiny rounding on top. So we have object number 1 and object number 2. Perfect. So now we created a water bottle starting as a direct model, not direct model, a solid modeling study. And then we created a rebuild with more fine control through the sketches. To save everything, the version where we only use solid shapes, please save as water bottle solid modeling. And then you will save this to the correct project folder. I will bring this to my 3D modeling. And then the bottle for where we use actually a sketch and then few features. We can save this one as water bottle sketch based. And then we save this also inside the 3D modeling. In your case, it's 2021 course, and save.